Okay, the fact that I'm on the assess now on page 38 means I've come to the end of section 3 or chapter 3 to do with fractions and decimals. There's a few questions I want to pick up though that look a little bit scary, and therefore I fancy doing them right now in front of you. I'm looking at question 12. A number is 0.05 and that's given to me correct to one significant figure, so that's 1 SF, and it says which of these numbers could it not be. Alright, so let me give you all the options. 0.045, we'll look at that. 0.0525, we'll look at that. 0.04, and loads and loads and loads and loads of nines, and 0.055, and the last one 0.0476. Let's take them one at a time. I'm looking for the one that cannot be rounded to 0.05 to one significant figure. Right, one significant figure. Remember, the first zero is insignificant. Chop, will that push it up to 5? Yes, it will. So that's going to become 0.05. That works. One significant figure again. One figure, chop. Will the 2 push the 5 up to 6? No, it won't. So it's going to stay as 0.05. One figure, chop. Will the 9 push the 4 up to 5? Yes, it will. 0.05. So that's correct. Next one. One figure, chop. Will the 5 push the 5 up further? Yes, it will. So that will give us 0.06. And just for completeness, chop. Will the 7 push the 4 up to 5? Yes, it will. 0.05. So the odd man out, so to speak, is that one, because you should round it to 0.06 to 1 SF, right? And you will not call it 0.05 because that would just be naughty and wrong. Next question, question 13, just looks a bit challenging without a calculator. That's why I fancy doing it to myself now. Right, Manish drove for 3.5 hours, so 3.5 hours, and he covered a distance of 215 miles. Got the picture? Driving for 3.5 miles, 3.5 hours, 215 miles. It says calculate how far he would go in 1 hour at the same rate, and then round your answer to an appropriate degree of accuracy. In other words, round it off sensibly. If I'm trying to work out how far I'm going to go in 1 hour, I ought to be dividing my distance by that time. So how far would I go in an hour? Well, remember, I'm not allowed a calculator, so already I'm getting a bit scared. However, if I multiply the top and bottom by 2, I will get 430 there. Yes, I will, if you double up. And if I multiply my 3.5 by 2, I've got 7. I can breathe a little easier because I'm now playing with whole numbers. Then I can take out my short division skills and revise that. Here I go. 7s into 4 do not go. 7s into 43 go, oh, I don't know, 6 times. Yes. 6 7s are 42. 1 left over. 17 into 10 once. What's left over? 3. 17 to 30, of course, decimal point now. 17 to 30 go 4 times. Now I'm going to stop there. In terms of an appropriate degree of accuracy, I want to call that 61 miles. So that's going to be approximately 61 miles. All right. I don't want to do anything more like that. There's a reciprocal question or two. I'm not going to do that, but I will do some of question 18 because these are recurring decimals that I should be converting to their lowest terms. So this is like the top end of grade B, but I think they're grade A's. 0.55555, a bit easy really. I will go for B though, it looks terrifying, and it's got this. I'll do it my way. Let x be 0.40404040. Is that alright? So it goes 404040. So it recurs as follows. Let me just rewrite it. 0.4 recurring and the 0 recurs. I'm going for 100 x's just to clear the fence. Doing doing. 40.40, that keeps recurring. take away now. 101x leaves me with 99x's if I subtract them. 40 and the point 4s and zeros that recur get cancelled because I'm taking away. Look, see, minus means take away, and I'm left with 40. Therefore, x is going to be 40 over 99, and you can't simplify that one. So 0.40404040 is basically 40 over 99. I think I'll try the next one. C, just over here. I'm going to let x equal 0.624, and that's how it recurs. Oh, don't need that one there, do I? I just want to move that recurring along a little bit. So it's like that. So it goes 624, 624, 624, just like a tango. So 1,000 x's should clear that nicely. That will give me 624.624. Of course, that will carry on recurring ad infinitum. Therefore, 1,000 take away 1x will be 999 x's, and as is usual, all these wonderful little recurrings will disappear, and we've got 624. So x is going to be 624 over 999. Now, can that simplify? I honestly do not know. I suspect 3's goes in. Let's just try it. 3 goes into 999 3 times. I can see that one. Now, 3 lots of 200 make 600, and 3 lots of 8 make 24. So I reckon we're looking at 208. So if I put there 208, at least I've divided 624 by 8. Right, so I've basically divided by 8 there. That's what I've done to get that. Can it go further? Well, the 3 looks a little bit ugly there, so I'm going to stop there, and I'm going to say that's just about it. Let's just turn over, do a couple of these horrible things. 1.27272. In other words, the 2 and the 7 recurs. Alright. Now I'm going to leave the 1 alone because that's not going to change at all. I'm just going to say let x equal 0.27 and let it keep recurring. I want to go for 100 x's just to clear that. So it's 27.27 recurring. And 100 take away the 1 is 99 x's. 99 x's, again, the 0.27's disappear, leaving me with 27. I'm sure I can do this with my head. 27 over 99. 3's going nicely, I think. Yeah, 3 9's going there, and 3 goes in there 33 times. Yep, 3, that's good. 3 goes in again, so 3 times. 3 goes in 11 times. So final answer, 1.27 recurring and recurring. It's basically 1 and 3/11. What about the last one? Well, I'm going to take a risk. I might get unstuck. You know, if I get unstuck, I'll just delete it and pretend that I didn't mean to do it. So here I go. X equals 2.123123. Oh, it's another one of these tango sums. Right. So, in fact, they just ditch the 2 and play with this part only. So let's not call it x then, because that'll be inaccurate. So now was let the x part that I'm going to work with be 0.123123. Let's go for 1,000 x's just to clear it. 123.123. This carries on recurring forever and ever in that direction. 1,000 take away 1, 999 x's will be 123 points. This take away all of those because they're recurring and they cancel. X is going to be 1, 2, 3 all over 999. I can't for the life of me seeing that simplifying. That 3 on the end makes me really nervous. So basically my final answer is this. 2.123, which recurs from 1 to the 3, is going to be 2 and 123 999s. Now just to cheat a little bit, I want to see if I can simplify it using my ABC button. I don't think it does though. So 123 ABC button 999 equals, oh my goodness, it does. It's 41. Oh shame. So it's 2 and 41 333. So 3 41s, 120, 3 1s are 3. Shame on me, I should have known. But anyway, I will get over that. So there you go, it's 2 and 41 333rds to be precise. Anything else on the assess? No. There's an exam question. Let me just see if it's worthwhile doing it. Box of counters, blah blah blah, red, white, blue. Yeah, how many counters are in the box? I don't know. Let's try it. Let's just turn over. If I find I go over a certain amount of time, I have to delete it from the video. A box of coloured counters contains only red, white and blue. So let's just see if I can do it off the cuff. Red, white and blue counters. A quarter, is it a quarter? No, a third of them are red. So a third of these are red. A quarter are white. And the remainder are blue. I've got 100 blues, actual proper 100. How many counters are in the box? Okay, well here I go. I've got a third red plus a quarter white. Let's do fractions. Right, lowest common multiple of 3 and 4 is 12. 1/3 is 4/12. 1/4 is 3/12. Altogether 7/12. Didn't come out very well. Now look, if I've got 7/12 are red and white, therefore my blues must be the remaining 5/12. Have you got that? Alright, so these come to 7/12. That little lot. So the remaining 5/12 must be 100 because I've got 100 blues. How many counters are in the box? Now look, take it easy. Now 5/12 of the counters in the box, call it X, comes to 100 blues. Alright, 5/12 of the number in the box is 100. Got a little equation. Look, 5x divided by 12 equals 100. Take the 12 and multiply. 5x equals 1,200, and x is going to be 1,200. Divide that by 5. Looks scary. I'm trying not to look nervous on the video. 5's into 120. Well, 5's into 100 go 20 times. 5's into 20 go another 4 times. I've got 24 times plus that extra 0, 240. There are, behold, 240 counters in this little box. And I'm very happy. Are there any more on the other side? No. Brilliant. In which case I'm stopping. You get on and revise and work hard.